Hello students, welcome to Boundless Maths, where we make maths not just understandable but also enjoyable. In today's video, we are going to cover the topic time-based data from class 12 Applied Maths CBSE curriculum. This chapter carries a weightage of around 5 to 6 marks in your board exams. So there is for sure a 5-marker question from this chapter and 1 or 2 MCQs also. So for the MCQs, you need to be clear on the theoretical concepts behind the analysis, and for the 5-marker question, we'll have a look at some of the examples that will help you solve them. Next, we are going to cover certain calculation tricks also that will be helpful throughout when you are solving questions for time-based data. So watch the video till the end because you will come across certain valuable calculation techniques that will save your time while you are solving questions for time-based data. So let's get started. First, we'll cover the theoretical concepts behind this. So what is time-based data? It is a collection of numbers that have been collected over a period of time. It could be the sales of a company or the air quality index of a city, or it could be the population of a country, or maybe population of a state, or it could be the electricity bill of your house over a few months or over a few years, so that you are able to analyze the data and then come to certain conclusions or predict the future values, right? So the intention is to analyze and then predict future values. So there are different components of a time series. The first one is time series. The first component of a time series is secular trend. It shows a secular trend. Secular means it is a long-term trend for more than 10 years, and it shows either the trend is going upwards or downwards, or maybe it is stable in a particular range, right? Next is the cyclical trend. What is cyclical? Cyclical means when the trend shows something going up and then down, up and then down. So it is repeating after a fixed duration, that is called cycle, or the span of the duration. So this trend is for more than 1 year for sure, spanning till few years, and the keyword here is span or cycle, that is the duration after which the trend repeats itself. So this is a cyclical component which has a shorter duration as compared to the secular trend. Next is the seasonal trend. Seasonal doesn't refer basically to winter or summers, but it could be any kind of event because of which the sales or the numbers, they change their behavior because of certain event that has occurred. For example, around Diwali, the sale of lights or the sale of gift items increases drastically as compared to otherwise whatever happens throughout the year, right? So that is a seasonal trend. So it could be related to the season, but or related to any kind of event that has triggered a increase or decrease in the sale of any product. The last component is the irregular component. It is due to any unforeseen natural calamities, that is any changes in the data because of any unpredictable factors. So that comes under irregular component. So these all these components are denoted by T, C, S and I, their first initials. Now there are two models of time series analysis. The objective is again to analyze the data. So there are two models, additive model and the multiplicative model. As per the additive model, you combine all the components together and you come to the original value of data. And as per the multiplicative model, you get the cumulative by multiplying all the components together to come at the to get the original value, right? Even though these things are not there, like there are no questions based on these concepts, but you should know these from MCQ perspective. Now eventually we have two methods, method of moving averages and least square method for analyzing the data, analyzing the trend and then predicting future values. So what is the difference between the two methods? Let's first understand and then we'll do some questions related to each of them. So the moving averages, basically it is used to draw smooth curves. Basically it is used to analyze or understand the trend, whether the trend is going upwards, downwards or it is stable over a period of time. So it actually eliminates seasonal, cyclical or any kind of random variations that have been there temporarily for a shorter duration, but overall over a long period of time how the data is behaving, that is what is analyzed using moving averages. So if you look at this graph, the gray lines are showing you the actual values and the red graph, this red line is showing you the trend. So the trend is basically going upwards. So it is a 5-year moving average trend that is moving upwards, and the actual data was somewhere around this only. So it has actually smoothened the trend of the data, right? Now let's come to what is least square method. So least square method, this actually assumes that your data can be represented by a linear equation. It eliminates personal biases and it is used for predicting future values. So main thing here is it is used for predicting future values. And why it is called least square method? Because here we calculate certain deviations and the sum of the squares of the deviations is least. So what is least here? Sum of the squares of the deviations. So what deviations, how they are calculated, why they are least, we'll understand when we do the questions for the least square method. So let's start with the moving averages method. So moving averages method, the first step here is read the question carefully and see whether the duration given in the question is odd or it is even. So you have to find moving averages for what duration. First, understand that from the question. The second step is calculate the moving averages. The steps are little different for odd and even period. So we'll have a look at it, how to calculate it using examples. And the third step is plot the trend, draw the original values using a solid line and the moving averages that you have calculated using the dotted line. So this is showing you the trend, upward or downward, and this is showing you the actual values. So the objective here is first understand the duration of the average. According to that, find the moving averages and then plot them to analyze the data to understand the trend of the data. So let's start with the first example. The question says calculate the 3-year moving averages for loans issued by cooperative banks for farmers in different states of India based on the values given below. So you have a table given here and you have to find the average 3-year moving average. So 3 is an odd number. So that means the steps for odd are to be applied here. So the first thing is whenever data is given to you horizontally, write it in the form of a vertical column. So the same table, what was given in the question is here in a vertical column. Now moving average, what is average? Average is the sum of certain values divided by the count, whatever is the number of values, right? So now here you need to do 3-year moving average. So that means you will add the first 3 values, 41.85, 40.2, 38.12, whatever values are given in the question. So these are also called index. This is also called time index. Index values, right? So now these index values you need to add the first 3 because the question said 3-year moving average needs to be calculated. So find the 3-year moving total. First column heading is total. The first column that you create is total after you have written the data, 3-year moving total, right? So add the first 3 values, write the sum besides the center value. The center year was 2007 when you added for 2006, 7 and 8. So write the sum besides the center value, that is 2007. Then next is you move to the next block. Remove the first year 2006 and add the value for 2009. So now the block size is from here to here. So this is the next block for which you need to calculate the total. So add these 3 values, put the value around the center of these. Center of this was 2008. So I will write the sum after 2008. Likewise, you keep on calculating the moving total. Right now we are just calculating the total, not the average. So calculate the total for all the values given to you. Just skip the first value. Keep on adding the next value for the next block. So in the end you will have the total for blocks of 3s. You will have the total for each of these blocks. Now for each of these blocks, how do we find the average? By dividing by the count. So divide each of these values in the total column by 3 because it was a 3-year moving average. When you divide by 3, you get the 3-year moving average. This is what we need to find out. So you have the 3-year moving average, 120.17 divided by 3 gives you 40.6. 104.82 divided by 3 gives you 34.94. So likewise you could calculate the moving average for the given data in the question. right? Now how do we analyze? What is the purpose of calculating these moving averages? We have calculated the moving averages also. Now when we plot the data in the graph paper, on the graph paper, this blue line is showing you actual data and this orange line is showing you the trend data. So either you can use two different colors, but preferred is use solid line for the original data and dotted lines for the trend data. So this is how you get to know the trend, how it is moving. In certain questions, the question also says what kind of trend do you observe. So you have to mention that the trend was going upwards or going downwards or it was a stable trend, right? Let's look at another example where we need to calculate moving average for an even duration. So the question says compute the trends by method of moving averages assuming 4-year cycle. So here 4 year is an even number, that means we need to use the even duration method here. Now again tabulate the horizontal data in the form of a vertical column. So in the form of vertical data column we have the data here, year followed by index number. Now whenever you have an even year duration for moving averages, while making the column, make sure that you are leaving these one lines, write one line of data, leave one blank line. Next year, leave one blank line. Next year, leave one blank line. Why we are leaving one blank line? Because we need to write certain values in these blank lines to make the data look neat and without making any mistakes, you can solve the question. So please leave one line between every two rows of the data. So once you have tabulated the data vertically, for 4-year moving average, we need to add the first 4 values. Added the first 4 values, you got 1730. But because there is no center value or the center year across which you should be writing the total, so what you will do is, you will write the sum of first 4 values in this blank row. Sum of first 4 values is 1730, so it is not against any of the year because there is no center year here. Right, because 4 is even. So that's why we have left this row blank and here we'll write the sum here 1730. Again, you calculate the sum of next 4 years. Now when you are calculating the sum for the next 4 years, you can use a shortcut here to do all these calculations, otherwise it looks too much cryptic, you have to do so much of calculation. So what you can do is, look at the first value that you have thrown out of the block and look at the last value that needs to be included in the block. It is 400 here and 432 here. So what is the difference between 400 and 432? It is just 32. That means whatever value you had just calculated, the sum of first 4 blocks, add 32 to that and you get the next sum, next moving total. Now again when you have to calculate the next moving total, you see what is the difference between 470 and 475. It is just 5. That means if you just add 5 here, you get the next total for the next moving total, right? Similarly, you can keep on calculating the moving total for a block of 4 years. Now once you have the moving total, it has to be averaged out because it is a total for 4 years. So divide all these values by 4. 1730 by 4 gives you 432.5. Likewise, divide all the values of this moving total column by 4 to get the moving average. Right? Now you have got the moving average for every 4 year. But because these values are not against any time point, there is no year here. So what we need to do is, once you have the moving average, take out the average of every two years, every 2 data points. So add them, write the total. So this column is headed as centered total. So you are trying to center that 4-year moving total to a year. So this is called centered total. So you add these two, write the sum. Next, add the next two, write the sum. Add the next two, write the sum. So this is how now you get the centered total column filled up. Now again, because it is a total of 2 values, again it has to be averaged out. And where do you write this? The row between these 2 moving averages, that is corresponding to the first year here in this question, 1982. So the first center total is across 1982. Again divide this by 2 to get the average, centered moving average. So the heading for the last column is centered moving average. So the headings for all the columns, 4-year moving total, first you calculate the total, then the average 4-year moving average, then the centered total, and then the centered moving average. Understood? Perfect. So this is how you calculate the centered moving average for every block of 4 years. Now in this case you do not have anything for the first 2 rows and the last 2 rows. In the previous example, for odd number of years, you did not have anything, any moving average for the first and the last year. But there were values for all the years in between. So here we do not have any data for the first and the second year and the last 2 years because it is a block of 4 years now. So I hope the method of moving averages is clear. So now let's move to the method of least squares. This method is normally just used to analyze the trend of the duration for which you have the data, right? Now the method of least squares is used more to predict future values. And here we assume that the data is following a linear trend that can be represented by a linear line. So the equation for a linear line is, equation is y is equal to a plus bx, equation for a linear graph. So this is the equation of a straight line. If I do sum of all the terms of this equation, I get sigma y equals, because a is a scalar, a multiplied by n makes it na. Then the sum of bx, b is a constant, so I write it first, and then sigma x. So if I do summation of this statement for a straight line, I get sigma y is equal to na plus b into sigma x, right? Then now if I multiply all the terms of this statement by sigma x, so I get sigma xy equals a into sigma x plus b into sigma x square. Fine. Now if sigma x is 0, if I put sigma x as 0, these terms will go away. If sigma x is 0, it doesn't mean sigma x square also has to be 0, right? If sum of certain numbers, for example 1 minus 1, 2 minus 2 is 0, that does not mean sum of their squares is also 0. So sigma x square is not 0, only sigma x will become 0. So if I just rearrange them, I can find the value of a as sigma y upon n, and the value of b from the second equation as sigma xy upon sigma x square. Now this might look a little cryptic. What is the sigma notation and straight line and how do we do that? But it is very easy. When we do the next 2 questions, you'll understand it better. So the intention of the least square methods is, first you need to create this, represent the data using a straight line equation. For this equation we need the values of a and b, and we calculate the value of a and b using these 2 formulas. So you need to calculate what is a, what is b, find the straight line equation, and using the straight line equation, once you have the values of a and b, you can predict any future value corresponding to a given value of x, right? So let's do some practice questions and understand it. The first question says, given below are the consumer price index numbers for industrial workers. Find the best fitted trend line. You have to find the trend line equation by the method of least squares and tabulate the trend values also. Fine. So first step, again you need to make a vertical column, vertical table for the values given to you. Count the number of years, 1, 2, 3, 4, 5, 6, 7. So n is 7. Here again in the method of least squares, there is little difference in when you have a value of n as even or odd. Based on that the steps vary little bit. So how do we do that? Here n is 7, which is odd, right? So for odd number data, what you do is just make the column first. Now we know that the value of a is sigma y upon n, and the value of b is sigma xy upon sigma x square, right? So that means our data just has a, right now it has only x and y, 2 columns. So first thing is we need to have x square and xy. Now before we calculate x square and xy, because we have bigger numbers here, we assume one of these rows, one of these values as origin. So 2017, the year 2017 here becomes the origin because we have odd number of values. The centered or the middle value is 2017. From both the ends, the center value is 2017. So 2017 becomes the origin, and corresponding to the origin we write x as 0. So this column is for deviations, deviation from the origin. The way we used to have assumed mean when we calculated mean in grade 10, we assume one of the values as assumed mean and then calculate upwards and downwards the deviations from that assumed mean. So similarly from the origin you calculate the deviation upwards and downwards. Upwards you will get -1, -2, -3 and downwards you get 1, 2, 3. For odd number of years it is very easy because you have a center value which can be assumed to be 0, which can be assumed as the origin, and then accordingly you have 1, 2, 3 or -1, -2, -3. As you can see, some of this column is 0. So when this is 0, A is sigma y upon n. What is sigma y? Just add all these index values. You get 1065, 1065 by 7 gives you the value of A. Now for calculating value of B, you need the product of x and y column and the square of x. So the next column, x square, it's very easy, 3, 2, 1, you just square the values, you get 9410149, right? The sum of these values is 28. Next you find the product of x and y. 145 into -3, -435. Again just find the product of these two columns, you get the column for xy, and the sum of this column comes out to be 465. Fine. Now the value of B is sigma xy upon sigma x square. So it is 465 divided by sigma x square is 28. So the value of B comes out to be 16.6. So the question says find the best fitted trend line. So the trend line equation is going to be what now? Y equals A plus Bx. A is 152.14 plus 16.6 into x. So this is the trend line, best fit trend line, right? And tabulate the trend values. You need to calculate the trend values also here in this question. Now again the shortcut here. How do we calculate the trend values? We put in the value of x, -3, -2, -1 in this equation and calculate the trend values from the equation that we have just derived. But a shortcut would be, look at this equation. If the value of x is 0, this factor becomes 0. So we have only 152.14 left for y. So that means corresponding to the row where we have 0, the value of y is 152.14. We have this value? Yes? So now the value of x is increasing downwards and decreasing upwards. The other factor is 16.6. This is the constant part, 152.1. This is the variable part that is based on the value of x. So now if you add 16.6 here, you will get the next value, 168.7. If you again add 16.6 here, you will get the next value. If you again add 16.6 here, you will get the next value. If you take away 16.6 from 152.1, you get 135.5. If you take away 16.6 again, you get the next value. And now if you take away 16.6, you get the first value. So rather than doing calculations like this every time, the shortcut is you start from the 0th row where you have x value 0, deviation is 0, so that gives you that constant value, and then this variable part you keep on adding or subtracting. So you get the table completely filled up now. So these are the trend values. Now suppose the question also asked you what is going to be the predicted value for the year 2022. So you just see what is going to be the deviation for 2022. Till 2020 it is 3. 2021 will be 4. 2022 is going to be 5. That means the value of x is 5. So just put the value of x as 5 and do the calculation. You get the index number for the year 2022. So you got the future predicted value also, and you could see the trend also. You can plot the index number with solid lines, the trend value with dotted lines to see the trend, how the graph is varying if the question says so. And to find a future predicted value, you just put in the value of x. Now don't put the value of this year, put the value of this deviation x into this equation and find the value of y. Done? Wonderful. Now the next question is for even number of years. Based on the data available for the sales of an item in a district by the method of least squares, tabulate the trend values. Similar to the previous question, we have to find the trend values for each of these years, find the best fit for a straight line trend, best fit equation, linear equation, and compute the expected sale trend for the year 2002. So the data is till 2001 and we have to compute the expected sale for 2002. So the first step is again you tabulate your data vertically. How many years? 1, 2, 3, 4, 5, 6. So here n is 6, which is even. So for an even year we don't have any center value. The problem with even number of numbers is data points is there is no center value. So how do you find the center? Remember how you used to find the median. If there is a center value, that becomes a median, but there is no center value, there are even number of numbers, then the average of the middle two becomes the median. So similarly, out of all these values for x for the year, the center two are these, and the average of these two becomes 1998.5. And if we use 1998.5 as the origin, then everything is going to be in decimal numbers. So to avoid that, what do is, from the origin, we find the deviation and then divide it by 0.5. So that we don't get any decimal numbers here. Now this is not difficult once you do it. So for example, 1998 minus 1998.5, it is 0.5. 0.5 divided by 0.5 is minus 1. So it was minus 0.5, right? So it is minus 1. Now if you see, the gap between these two is of 2, 2, 2. Here it is 1, 3 and then 5. Sum of this column is anyway 0, which was our assumption. So now again we find the value of A. How do we find the value of A? We don't need any columns for finding the value of A. That's pretty easy. Just find the sum of this column Y. It is 35.6 divided by total N, that was 6 in this case. So the value of A is 5.9. Right? Now to make the calculations easier, the first step we did was division by 0.5. Again we will see how to make the calculations easier in the last step. To find the value of B, sigma xy, you add all the values of sigma xy. X square and then x multiplied by y gives you sigma xy. Again you find the sum of this column, it is 9.2. Sum of the x square column is 70. So that means the value of B is sigma xy upon x square. That is sigma xy is 9.2. 9.2 divided by 70, that gives you 0.13. So the value of B is this. So that means the trend line is y equals 5.9 plus 0.13 x. So this is my trend line equation. Y equals 5.9 plus 0.13 x. So the steps were to find the value of A and B, put them into the equation and you get the trend equation. Now once you have the trend equation, you can find the trend values for each of the given years also if the question is asking you, or you can find the predicted value also by putting the values of x. Now here you don't have any 0 here. There was no origin 0 value here. So what you do is you calculate the first value. The x is minus 5. Yes? So 5.9 plus 0.13 into minus 5, you do this calculation, you get 5.25. 5.25. Now what is double of 0.13? 0.26. Yes? Why double? Because the gap here between two consecutive values is 2. So you just add 0.26 to this value, you get the next value. Because there was no 0 value, no origin with the 0 value here corresponding to any year, we started with the first value, calculation of the first value. After that, you keep on adding plus 0.26, plus 0.26. So when you keep on doing that, it is a simple calculation. You just need to add 0.26 for all the successive values and you have all the trend values for your data. Easy? So that makes the calculations easier here. And when you have to find the predicted value for 2002, how do you find the predicted value now? In this case, because you have done division by 0.5 also here and the origin is 1998.5, so for the year 2002, you will first subtract the origin 1998.5 and then divide it by 0.5. What is the difference between these two? 1998, 1.5, 3.5. 3.5 divided by 0.5, you do this calculation and then you put this value into this x variable in the equation. So the equation becomes y equals 5.9 plus 0.13 multiplied by the value of x you calculated here. So just be careful when you are calculating the predicted value, it is the x is the deviation. So it has to be subtracted from the origin and then divided by 0.5 because we have used it that was only throughout. So only the deviation, the difference should not be taken here, it should be difference of the future year minus the origin divided by 0.5 because we have done division by 0.5. So that gives you an easier solution for the predicted value. So I hope both the methods are clear, the method of moving averages and the method of least squares. What I'll suggest, practice at least 3-4 questions for both the methods, and you should pick up any of these for your board exams, whichever has odd moving averages or odd years for the least squares, because odd one calculations were easier for odd values. When you had even moving averages or even period for the least squares, then the calculations were little more, right? So whichever method you are comfortable, because there is going to be a choice. There is always a choice for a question on time-based data. Either you attempt the question for moving averages or you attempt the question for least squares. So either of them can be attended, but the preference should be given to wherever you are given odd number for moving averages or you are given odd duration for the least squares method. So I hope you understood the two methods and you understood the calculation techniques also, how you can make them easier. So all the best. If you like the video, do share the video with your friends. Click on the subscribe button, click on the notification bell icon so that you keep getting notifications on future videos, and don't forget to subscribe to the channel Boundless Maths. Thank you.